Hello, welcome. Today we'll talk about energy and problem that uses energy dynamics. The equation for working kinematic problem involves a particle that can be derived by integrating by equation of motion F equals ma. With respect to displacement by substituting at v equals d
Teacher, I can barely hear you and I'm right next to you.
ft equals mat. The result integrated to the yield an equation known as the principle of work and energy, Fds equals mdv. This principle is useful for solving equations that involve force, velocity, and displacement. It can also be used to explore the concept of power. To use this principle, the first understanding calculate the work force, and that's it. A 5 kilogram block is moved up 30 degrees incline by a force of 50 newtons. Parallel to the incline, the coefficient of kinetic friction between the block and the incline is 0.25. How much work is done by the 50 newtons force in moving the block distance 10 meters? What is the total work done of the block over the same distance? So for this problem, we have to draw a free body diagram, but I already drew it, so I'm just going to explain what's going on. So, see, here's the block, and the force is acting on it: force normal, force friction, and the applied force is 50 newtons. And right here, this is what we're looking for. This mg cosine equals 30 degrees, which mg sine equals 30 degrees, which is both of these, and the angle of 30 degrees. Because of its weight, mg of the block experienced a force down incline of magnitude mg sine 30, which equals 5 times 9.8, which is gravity, times 0.5, which equals...
Teacher, can you please write it? Because you're doing it in your head. It's making me confused. Thank you, teacher. Please demonstrate it.
I'll explain it when I'm finished.
Okay, calm. You feisty teacher. Teacher, why are you doing so fast? I don't get it.
I'm a beast. Okay, so this is what we have.
You're so smart, teacher.
mg sine 30, which is this, will equal 5 times 9.8, which is the gravity, times 0.5 will equal 24.5 newtons. In addition to frictional force, which is felt opposing to motion that's down the incline, its magnitude given by Fk equals U Fn, which also equals 0.25 times mg cosine 30, which equals 10.6 newtons. So, in addition to the normal force and the component of gravitational force that is perpendicular to the incline, it cancel exactly. Thus, the net force acting on the block is 15 newtons. 15 newtons minus 24.5 newtons minus 10.6 newtons, which equals 14.9 newtons. They're directed up the incline. It is net force that is exerted a line or a I net work of the block. Thus, the work done a block is W equals Fx, which equals 14.9 times 10, which equals 149 joules.
Can you please demonstrate
yes,
that? Teacher, have you been doing it in your head? You're so smart. You're smarter than an Asian.
I'm the human calculator.
That's really nice. Teacher, some people don't know the equation.
W plus Fx.
Or you can say equal Fd, because x is distant. Right, teacher?
Yes, now.
Thank you, teacher.
Thank you for this lesson. See you again.